Hello everyone. In this video, I'll be explaining AWS X-Ray, a powerful tool for analyzing and debugging application in production and distributed system. And I'll be covering all these topics, that is what it is, why we need and what are the key features and how the AWS X-Ray will work and what are the key benefits we have and the example scenario of the AWS X-ray. So let's understand one by one. So, what is AWS X-ray? So, it is a fully managed service that helps developers to analyze and debug distributed applications such as those built using microservices or a serverless architecture. So, fully managed means it is a service provided by AWS that you don't have to worry about maintaining or managing. AWS takes care of everything of you, such as scaling the services or handling the infrastructure. And also, I have told you it helps for the developer. It's especially designed to help developers to analyze and fix issue in their applications. And it's a distributed application. The applications that are spread across many services or components, for example microservices or a serverless architecture, or example of distributed systems. And also we can analyze and debug this, so help us to figure out what's going wrong in your applications and make fix faster. So, and also it provides end-to-end tracing of requests as they travel through an applications, allow you to identify performance, bottlenecks, errors, and issues within your services. So end-to-end tracing means when a user make a request like logging in or making a purchase, X-ray follows the request through all the services in touches. It tracks each step of the process so you can see how the requests flow through the applications. And also I have specified that it's identify bottlenecks, errors and issues. It shows where the request is slowing down or failing. For example, if a payment services takes too long to respond, or if there an error in a database query, X-ray will highlight those issues so you can fix them. X-ray capture detailed insights into the request journeys, breaking them down into individual segments, which can be visualized through its services map and a trace data. Detailed insights gives you a deeper understanding of what happening when a request move through your application. It provides detailed information on each step of the process, and also it divides the request into smaller parts or the segments. For example, one segment might represent a database cell or another represents a service that process the data and so on. These allow you to see where there are things longer or going wrong. And also it represents all the information visually through a map showing how your services are connected and how the request flows. You can also view raw trace data that gives you more specified details about each step in the request journey. So the next topic is why we need AWS X-Ray. So it is essential for modern applications, especially those built with microservices or serverless architecture, as it provides deep visibility into the performance and behavior of these complex systems. So AWS X-ray is important for modern application, especially though are using multiple small servers or running without managing servers. It helps you to see how each part of the application is working and interacting with others, give you a clear picture of the performance. So without X-ray, troubleshooting performance issues, errors, or a bottleneck become challenging, as traditional logging and monitoring methods may not provide enough content or a detail. So without X-ray, finding out why your application is slow or having issues is harder, because basic logs only tell you that something went wrong, not why or where it happened. You don't get full picture of how everything is connected. So and X-ray helps identify slow requests track the flow of transaction across services and highlights any failure or latencies, enabling developers to resolve issues faster. So if find out which part of your application is slow, track how requests move between services and show where things went wrong. These make it easier and faster for developer to fix the problem. So that's why we use the AWS X-Ray. So let's understand what are the key features of AWS X-Ray. So the first key features we have is it is a end-to-end tracing. So it traces a request as they travel through your entire application from the front end to the back end services. So by providing a detailed journey of each request. The second feature we have is a service map visualization. So it's create a visual map of your application services and their interactions, allow you to easily identify performance bottlenecks, errors, and a dependency. The third feature we have is a automatic data collection. X-Ray automatically collects trace data from AWS services such as EC2, Lambda, API gateways, and a DynamoDB, eliminating the need of your customer instrumentions. So the fourth features we have is a root cause analysis. It helps to identify the root cause of errors or performing issues by breaking down trace into segments and sub segments, allow for granular analysis of each service involved. And the fifth features we have is a error and a exception tracing. It tracks exceptions and error, providing detailed information about where the issues are occurring, which helps developers to troubleshoot effectively. And the next last features that we have is a latency and a performance insights. It highlights a latency hotspots into your applications, helping you optimize the performance of your services by identifying the slow operations. So the next topic we have is how the AWS X-ray will work. So AWS X-ray works by collecting the trace data from your applications to provide deep insights into its performance, errors, and behaviors. So here is a simplified explanation of how it will work. So it's instrumenting the application. First, you need to instrument your applications by integrating AWS X-Ray SDK into your code. These allow the applications to send trace to your X-Ray when it processes the incoming request. Generating the trace. When a request is made to your applications, X-Ray automatically generates a trace for the request. These trace is a collection of data about how the request travels through your application, which services and resources interact with, and how long each operation takes. And it's creating a segments and a sex segments. Each trace is broken down into a segment representing individual operations, and these segments can be further divided into subsegments if needed to find detail, such as specified operations or functions called within a services. Sending trace data to X-ray services. The trace data is sent to AWS X-ray where it is processed and stored. These data include details like response time, error messages, and exceptions encountered. The next one is visualizing data with service maps. X-ray visualize the trace data in a service map which shows how different services within your applications are connected. These maps help you to easily identify performance bottleneck errors and latency issues by seeing the interaction between services and pinpointing where delays or failures occurs. Analyzing and debugging. Using the X-ray console, you can drill down into specified trace, view detailed segment information, and analyze any errors or latency problems. You can also use the features like annotations and a metadata to customize the data and gain additional insights. Continuous monitoring. AWS X-Ray continuously collected and update the trace data for ongoing monitoring. You can use this information to optimize your applications, identify areas for improvements, and ensure its reliability over the time. So, by providing a comprehensive view of the result lifecycle and a detailed performance metrics, AWS X-Ray makes it easier to monitor, troubleshoot, and optimize the distributed applications. So, this is how the X-ray will work. So, let's understand what are the key benefits we have in AWS X-Ray. So, the first benefits is it's a improved application visibility. It's provide detailed insight into how requests flow through your entire applications, giving you a clear understanding of the interaction between the services. This is particularly useful in microservices architecture where tracking individual services performance can be challenging, and it is a faster troubleshoot. It helps identifying the root cause of issues by providing granular data about errors, latencies, and performance bottlenecks. You can quickly pinpoint problematic services or operations, reducing the time spent on troubleshooting. Performance optimization. So, by analyzing trace data, you can identify slow services or resource intensive operations. So, these allows you to optimize your application's performance, ensuring a better user experience and a more efficient use of the resource. Distributed tracing. It's track requests across multiple services, make it ideal for distributed system or a microservices or architecture. It's provide end-to-end tracing, allow you to visualize how requests are processed across different services. Service map visualization. X-ray service map provides a visual representation of how services are connected, making it easier to understand dependencies and relations. These can help identify performance bottlenecks, misconfigurations, and failure points. And it also integrated with the various AWS services. It seamlessly integrated with the AWS services such as Lambda, EC2 instances, DynamoDB, or the API gateway. These integration provides a view of AWS based infrastructures and services. So let's understand the example scenario of e-commerce applications for the AWS X-Ray, how it will work. So here the problem we are giving is an e-commerce application built with the microservices is experiencing a intermittent slow response times during checkout. Customers are reporting delays and the deployment team is unable to pinpoint the exact cause of the issues. So these application consisting of several services such as user services, product services, order services, payment services, and the inventory services. So the team has no clear understand of where the bottleneck or failure is occurring, and traditional logging is insufficient due to the complexity of the microservices architecture. So these are the problems they are facing. For this, the solution we have given by the AWS X-Ray is instrument the application. The team integrate the AWS X-Ray SDK into each of the services in the applications, like user services, product services, that what are the things I have mentioned, ensuring that the trace data is collected whenever the request flow through the system. That will check. Generate trace. A customer visits the site, log in, view a product, and adds it to the cart and proceeds to checkout. So the checkout process involves multiple calls, its authentication, product detail, order creation, payment process, or an inventory update. Each of these requests is traced as it is in AWS X-Rays. So data collection and analysis. As the trace data is collected, X-ray creates a trace map of the entire checkout process. The trace shows the request journey, including the time each services took to respond and whether and any occur during the processing. Visualizing the service map. The X-ray service map visualizes the interaction between services in real time. The development team can see that the payment services is taking much longer than other services, resulting in a delay in the overall checkout process. Root cause identification. The team drills down into the trace for the payment services and discover that the issue lies with an external payment gateway API, which is causing the delay due to high latency. The payment services is waiting too long for a response from the external services. Optimization. Based on the trace data, the team decide to implement a retry mechanism for payment transaction and add timeouts to prevent the log waits. They also optimize the service code to handle slow external API calls more efficiently, possible by switching to different payments provider or caching certain data. Monitoring and resolve further issues. After implementing the changes, the team continues to monitoring the application using AWS X-Ray, which continuous trace data collection. They can spot any new performance issues or failure quickly, ensuring that the e-commerce sites run smoothly for the customers. For the problem, we have given the solutions and what the outcome we can get from this. Using AWS X-Ray, the team was able to quickly identify the root cause of the performance bottleneck, optimize the applications, and significantly improve the checkout process. These result is faster transaction times, better customer experience, and fewer support tickets related to slow the response during the checkout. So this is the example scenario of the e-commerce application have given to the example for the AWS X-ray. So the topic I'll covering everything. So this is the theoretical part of the AWS X-ray. So let's move to the AWS account. I'll show you how to demonstrate or implement and how to check all those things in a AWS account by using a AWS X-ray. So let's start with the practical thing. So here we need to implement X-ray, AWS X-ray, right? So it is implemented with the it's the feature of the CloudWatch, and you can go with the CloudWatch. In the CloudWatch also you can see the X-ray features, or else see in the CloudWatch you can see with the X-rays, or else if you want to go with the AWS X-ray only, you can go with that also. So you can move with this also X-ray. It's moving to the CloudWatch management only. So see here we have our X-rays. So this is implemented with the CloudWatch only. So go to trace. So here, so we need to set up a demo application here. So let's go and set up a demo application here. So see, it's a launch a sample applications of the Java, create a sample application with the cloud formations. So here they have given some steps. So or you can view sample map when done. So let's create on a click on create sample applications with the cloud formation. So here choose launch sample applications, choose next, and they are giving the steps to create a sample application for us. Let's go and create a sample application. So let's so here they have given a create a stack for a prerequisite. Pre Here we need to prepare a template. Here they have given two options. One is choose an existing template or build from the infrastructure composer. So just here we are creating a sample applications with whatever they have given. So let's choose on this. So and we have specified the S3 URL and Amazon S3 URL. They only specify the region and the name of the S3 bucket. So click on next. So here they have specified some stack details, and here provide a stack name called X-ray sample. Let it be that only. So here parameters are defined in a template and allow you to input custom value where you create or update a stack. And the maximum size, here you can give any maximum size. So for learning purpose, here we are giving the only one maximum size, and assign a public IP from the inherit. And see here they have device name and a volume size and a volume type, everything they have mentioned. And also they have mentioned the instance types, everything they have mentioned. So rest of the thing will be same. See, they have provided the subnet CIDR block numbers, and also they have provided, and VPC CIDR block also they have provided. The rest of the thing will be same. Click on next. So here configuration stack operation. So here, if you have an existing IMA role which associated with this X-ray, you can specify this here only, or else you can leave as it is because they have mentioned optional. And stack failure options are rollback all stacks resources, let it be, and delete newly created resource during a require. Click on delete all the newly created resources. So on the advanced option, everything is there. So here, enable this one. I acknowledge that AWS close mission might create IMA resources with a custom name. By this, they only created the IMA role for that one. So click on next. So review and create. So the template is ready for us. So see here, this will be created here. So that's the rest of the thing. So click on submit. So see, the creation is in a progress. So let's go to the resources and see what are the resources here they creating for us. So they're creating VPC for us, DynamoDB, IAM role, SNS topic, everything will be created. And let's go and check one by one whether the resources are creating for us or not. So first I'll open everything. So let's check whether the VPC is created for us or not. So as the X-ray sample VPC has been created, and when it go to SCT instances, let's check whether the instances is created or not. Still it is not created. So let's check lambda whether the function is. So let's check with DynamoDB. See, the instance is in a pending state. That means it will going to create a EC2 instance for us. Let's check with the load balancer whether the load balancer is created or not. Yes, the load balancer has been created, and let's check if the load balancer is created means obviously the target group also have been created. So let's check whether the group is created or not. Yes, the target group also created. Let's check whether the S3 whether the S3 is created or not. Still it's not. See, in the tables it has been created. Table has been created for us. So when it's go to the lambda function, let's refresh this one. So as the lambda function also created with the node.js, and it's also integrated with this. It has been attached to this. So all the instances has been created and the sample application have been started. So see, the creation is completed. Now what we need to do is go to load balancer and copy the DNS name and paste it in the Chrome. So see, whatever the action we are doing here, that will we can trace by we can trace those things. So see, already the trace has been started. So when you go to the recent trace, so see, the client is established the connection with the front end, that is container, and also the SNS. So click on create. The username will be random and the session game. Click on create. If you click on create, so let's go and check with the recent trace. See, the another trace has been created. See, that's a client established the connection with the ECS container, and it has this session expire connection with the DynamoDB table to load the data. So when you give the name, you can give the name anything, and the rules is a TikTok. So click on create. So click on play. So here at the scorekeeper, here we can play a XOX game, and when you come to Cloud Watch, and you can also track the recent things by clicking how the things will going work. See, the client established the connection with the front end, and the games has been started by collecting the data. So when you start playing with this, so the it will show X will win. And when you again come and trace the data, see, the It is showing the recent IDs and the trace status is okay and the timestamp 50.5 seconds back I have created and the responded code response time durations and in which HTTP mode it will created post put and get method it will created all the things will be showing. So this is how, and we can also view the trace of the game and view the service map. When you click on the service map you can see the things and all here, and also you can view the trace for this game. So see you when you enter to the recent trace, so it will show you the things. You can see the resources and all. um So this is how the when you can go to the trace map, you can trace the things like, see, it's the SNS is created, notifications, DynamoDB session created, everything will be showing here. So, and after creating all these resources, you don't have to worry about you want to go to delete the resource individually. Don't about think about this. So let's go to the cloud formation. Just click on delete button. The everything will be deleted. What are the resources created by the AWS X-Ray that all the deleted? So click on delete button and the make sure that if all the services has been deleted it will show that delete is completed. So by this AWS X-Ray, so the developers can quickly analyze the data and troubleshoot when there is any failures occurs. So this is how the AWS X-Ray will work with the sample application. So let's check whether the, let's check one by one whether the resources are deleted or not. See, the status is in a deleting state. Now go to your, see, shutting down and again refresh. Yeah, it has been deleted. See, the lambda function also deleted. Everything will be deleted when you click on delete in the cloud formation. So I have completed the every topic in a theoretical part, as well as the I'll also show you demo on the AWS X-Ray to by creating a sample application in AWS X-Ray. That's all about AWS X-Ray demonstration and how to analyze the things in a CloudWatch and X-Ray. That's all. Thank you.